Our question today is, what is momentum? Momentum is very similar to a topic we've already discussed, which is inertia. So let's review what inertia is before we proceed. Inertia is the tendency of an object to maintain the same motion. In other words, it is saying that an object in motion wants to stay in motion, or an object at rest wants to stay at rest. It is also known as the first law of motion. And so if we look at this a little deeper, inertia only depends upon the mass. The more mass an object has, the more inertia it will have. For example, if I have a bicycle and a car, and they're both at rest, and I want to get them starting to move. And so I give them a push. It is much easier to move the bicycle than it is to move the car. The bicycle has less inertia, so you can change its motion a little bit easier. The car has more inertia, and so therefore it's more difficult to get the car moving. So inertia only depends upon the mass. The more mass it has, the more inertia it has. Momentum is similar to this, but it is only the motion aspect of it. And so we define momentum as inertia in motion. In order to have momentum, you must have both mass and you must have velocity. So momentum depends on both mass and velocity. If an object is not moving, it has zero momentum. It still has inertia because inertia only depends upon the mass part of it, but it does not have momentum unless it's moving. So momentum, if we want a large momentum, we want a large mass, and we also want a large velocity. For example, if I want to break down a door, it takes a lot of momentum to do so. And so throwing something like a paper clip at a door is not going to break the door down. Instead, we need something heavy. And so a lot of times if a firefighter needs to get in a door because the house is on fire and they need to get some people inside, they're going to use a very large battering ram. And so it has a lot of mass. The other thing it depends upon is the velocity. You cannot break the door down to get inside and save the people unless you have a large velocity as well. So you've got to take that battering ram and they're going to swing it towards the door as fast as they can. So my question for you today here is down below in your notes, you'll see the question, how can an object have a large momentum? And what I want you to do is I want you to write your answer, and then we'll pause the video, write your answer, and once you've written your answer, unpause the video and see how well you did. So go ahead at this time, pause your video, and answer the question, how can an object have a large momentum? Welcome back. So you should have answered the question, how can an object have a large momentum? Your answer should be similar to this. It must have a large mass, a high speed, or perhaps both of them. So in order to have a large momentum, you must have a large mass, a high speed, or possibly both. So examples of things with a large amount of momentum would be something like an airplane flying through the air, or maybe a big 18-wheeler truck moving down the highway. They have both a large amount of mass and a high speed. Another example of something with a large momentum would be like the Earth. The Earth is moving around the sun, has a very large mass, and also a very large speed. Now our equation for momentum looks like this, where P stands for momentum. You might say, well, why not make M for momentum? And the problem with making M for momentum is that M is already mass, and mass is part of the equation for momentum. So we had to come up with a different letter, but why the letter P? Nobody knows for sure, but they speculate that the letter P stands for progress. Because when they first started talking about momentum, they talked about the forward progress of an object. The more forward progress it has, the more momentum it would have. So again, they speculate the letter P came from that term to progress forward. So our formula here is that the momentum, if I want to calculate it, it is mass times velocity. The unit of mass is kilogram. The unit of velocity is a meter per second. So therefore, the unit of momentum is a kilogram times a meter per second, which is written right here. If you want to solve for the mass instead, well, then we're going to divide the momentum and the velocity. And if I want to solve instead for the mass, sorry about that. If I want to solve for the mass, it is momentum divided by velocity. And if I want to solve for the velocity, it is going to be momentum divided by the mass. So depending on what we have and what we need to find, this circle here helps us to solve for the value that we don't know. One of my final questions here, I have two questions before you stop the video. The first question is, if a truck and a roller skate are moving down a hill at the same speed, which one has more momentum? So what I'd like you to do is I'd like you to pause the video and write down your response. And once you're done writing your response, unpause the video and see how well you did. So go ahead at this moment, pause the video, and write your answer to, if a truck and a roller skate are moving down a hill at the same speed, which one has more momentum? Welcome back. So you should have written your answer to, if a truck and a roller skate are moving down a hill at the same speed, which one has more momentum? And the answer to that question is, the truck has more momentum because it has more mass. It is way more challenging to stop the truck than to stop the roller skate because the truck has more momentum. The last question before you go is, can you think of a case where a roller skate and a truck would have the same momentum? So what I want you to do is I want you to pause the video and write your answer down. Can you think of a way in which a roller skate and a truck would have the same amount of momentum? And once you've written your answer, then unpause the video and see how well you did. Welcome back. So our answer to this question here, they could have the same momentum if the speed of the roller skate is much greater than the speed of the truck. For example, if we have a 1,000 kilogram truck backing out of a driveway at 0.01 meters per second, it will have the same momentum as a 1 kilogram roller skate going at 10 meters per second. In order to solve that, you take your masses and velocities and multiply them. So for the truck, we take 1,000 times 0.01, and we get an answer of 10. Likewise, for the roller skate, if I take my mass of 1 times my velocity of 10, I also get a momentum of 10 kilograms times meters per second. So both of them have an answer of 10. Because the truck has a much larger mass, it must also have a much smaller velocity.